Hello everybody, today I'm gonna present you a brief attack demo on two industrial control systems and show you how we can attack such systems. My name is Tawhid Shekari. I'm a third year PhD student at EC Georgia Tech and I'm working with Dr. Bea. And my lab mate who has helped me to prepare this demo is Chinchenju. So first, let's see which components do we have in our demo. We have uh, three computers. The first one represents the physical process. The physical process is modeled in this computer. It is communicating with the HMI and the PLC in the normal condition. So the HMI gets the different sensors and different measurements from the physical process to show in the screen, and the operator can see them and even initiate some settings to the PLC, which is our controller. We have used real PLC in this demo. So the PLC gets different measurements from the physical process and returns back the signals of the actuators to the physical process to control the process. And we have used the attacker's machine. The attacker's machine intercepts the packets, which is communicating between the physical process and the human machine interface, and the attacker replaces the packets with the spoofed ones. So the attackers initiate commands to the PLC, changing the setting of the program to cause malicious thing in the physical process while reporting normal operating condition to the HMI. And we will see how this is happening in real world. So the physical process will implement the malicious thing while the operator sees the normal operating condition. So this is our first scene. It's a production line. So the two types of boxes are generated at the beginning of the roller. Then at the end of the roller, there is a partitioner which separates the boxes. The small boxes are transferred to the right and the large boxes are transferred to the left. And at the end of those rollers, the boxes were removed. So we have start button, stop button, just to start and stopping the program. So let's see how this works. So we press the start button. The box is generated. It's a small box, and we expect that it should be transferred to the right roller. And this is the normal behavior of the system. So we have three boxes at the beginning, and we expect that all of these three boxes are transferred to the right hand side. And there is a large box right now, and this large box should transfer to the left hand side. But this process should be exactly seen by the operator through human machine interface or HMI, and we will see how this works. Alright, so let's go to the next part. Yes, this is the HMI. So in the HMI we have enable left conveyor, disable left conveyor, enable right conveyor, disable right conveyor. Just in emergency cases, the operator can control the conveyors, and it shows the status of the conveyors, left conveyor, right conveyor, and also we can see the Wireshark capture to see how these informations are coming from the real actually process. So also it shows the left counter and right counter showing the number of boxes that are separated. So if we connect to the PLC, so we will see that th there are two types of packets, read holding registers and read coils, which are responsible for reading the number of left counter and right counter, and also the coils, the status of coils, which is the status of actuators. And this is the attacker's machine, so we have a very similar HMI to the real HMI. The attacker can try from here to intercept the packets and disable the left conveyor, right conveyor, and as you can see, we disabled the left conveyor from here, and these are showing the actual status of the left conveyor, which is disabled. But at the same time, our code spoofed the packets going through the HMI, showing the normal operating conditions. So we will see how this works in practice, and we will see how the HMI looks like in the case of attacks, and how even the real process looks like in the case of such attacks. And as you can see, it doesn't work, so this means that yes, so this is the real process. As you can see, it is working correctly before we launch the attack. It separates different boxes, and since we disabled the left conveyor, the left roller stopped working, and we will see some kind of jamming in the system. And as you can see, the left conveyor is completely disabled and it doesn't work anymore. And yes, the jamming happened. All right. So let's see how the legitimate HMI looks like, because attacker spoofed the HMI packet, and as we can see, the HMI shows that the left conveyor and right conveyor are both enabled. There is no problem, and both of the left conveyor and right conveyors counters are incrementing, showing the normal operating condition. So the legitimate operator doesn't know anything about the attack until it is too late. And this is for the first scene. We actually created another scene for showing the effect of a similar attack, and we will get to that very soon. Okay, this is our second scene, which is a water tank environment. So there is a water tank, there is a filling valve here, and there is a drain valve here, and there are start and stop buttons similar to the previous part. If we press the start button, it's gonna fill the tank until 2 meters. After reaching the 2 meters, the level of water should be decreased until 1 meter, and this process should work in a cycle. So until we press the stop button. If we press the stop button, it should drain all of the tank. And there is another button which can be enabled by the legitimate operator from the HMI, which can, that is the manual fill. So if you press that button, it's gonna manually fill the tank, and the attacker will make use of this attack, in this attack. So as you can see, here is the normal condition. It's filling and draining in the specified levels, and there is no problem at all. The PLC sends the commands, reads the sensors, and based on those sensors values and based on its programmed logic, it decides which command and which valve it should operate. So in the next step, we will look at the HMI system to see how HMI looks like in this new scenario. Okay, I think we had enough here. So yes, and this is the HMI. So we connected to the HMI. It shows the water level. So it's always between 1 and 2, and it shows the filling and draining valves status. So the water level starts from 1 and it goes up until to 2, and then it again decreases to 1, and the level of the filling valve and the rate of the filling and draining valve, of course, they are changing. So again, by looking at the water capture, we can see how it works. We have read holding registers for reading these three values, and this is the attacker's machine. If we connect to the PLC, we can see this is now the legitimate condition and there is no attack currently. The water level is changing and we can see the filling and draining valve. Now let's enable manual fill from here. If we enable that, it should go about 2 meters regardless of the PLC program, and we can see that this happened right now. So we intercepted the packets, modified the enable manual fill, caused the malicious action, and at the same time we sent the legitimate condition to the HMI to hide our activity. And here is actually our scenario. Yes, so this is working fine before the attack, and after a few seconds we will see that how attack is implemented in the real process. So yes, I think this was the instant that we launched our attack, and it should go about 2 meters right now. Yes, so it went about the 2-meter level water, and we can see it overflows. This environment doesn't allow us to cause any explosion or overflow, but we can see that something malicious happened in the process. And again, this is our HMI, and we can see the attacker successfully implemented the packet spoofing. So the legitimate user and the legitimate operator doesn't see anything. He can see the normal operating condition, the water level is going up, down, and also the filling and draining valves are working perfectly fine. So he will not be able to see anything from his side until it is too late and we have something very bad happening in the actual process.